Hi guys, this is the notes for day 2 of section 2.2. We started off with a warm-up. We didn't do this together, but I wanted to make sure that you had the solution to it somewhere. You might see it again as a bonus sometime. Just saying. Never disregard warm-ups. So anyway, Jessie wrote down a 3-digit natural number. She said her number consists of 3 consecutive digits in descending order from left to right, with the sum of its digits equal to 24. So when we look at this, if we're talking about digits, that means it has to be an integer, right? Because if I've got a number, it's a 3-digit number. So say 2, 3, 4. Each of these guys have to be integers. I wouldn't have 2, 3.5, 4. That wouldn't make up a number, right? So we know they're going to be integers. And then it says that it's descending order from left to right. They're going to add up to 24. So here's my first number, plus descending means I'm going down 1 each time. So n minus 1. So starting number, the next number is going to be 1 less than that. The next number is going to be 2 less than that. And the sum of these 3 digits needs to add up to 24. And then it's just a matter of solving it. This is like a very common type of PSAT question or SAT question, so don't be surprised if you see it there as well. So I've got n plus n plus n, that's 3n, and the negative 1 minus 2 is negative 3. Oops. 24. And then I just solve for n. So 3, add 3, 3n is equal to 24 plus 3 is 27, divided by 3, n would be 9. So then the number that I'm looking for is 987. So if I descending order left to right, 987. 9 plus 8 is 17, plus another 7 would be the 24. So that really is not pre-calculus. It's just something to get your brain thinking, to get us going, and it's also something you might see on a PSAT. So hopefully that helps you out. On to today's notes, however. This is pre-calculus. So we're starting with what we were talking about yesterday, where we're coming up with the number of real zeros and turning points, and then we're going to find them by factoring. So for this first guy, my degree of this polynomial is 4. So the number of possible zeros is going to be 4. The number of possible turning points, which I'm going to call TP, is going to be 4 minus 1, which would be 3. And then it says determine all of the real zeros by factoring. So we're going to take x to the 4 minus 3x squared minus 4, and we want to factor this. So when I notice that it's not like 4, 3, 2, but it goes 4, 2, 0, that's my indication that I could take this quartic function and put it into quadratic form, make it look like something that I know how to factor. This I don't really know how to factor as is. But if I want it to look quadratic, that means I want it to look something like this, where this would be x squared and that would be x. But I need it to be x to the 4th. So x to the 4th is x squared, and then minus 3x squared. And now I've got it to look like a quadratic function where a is equal to x squared. So this is the same thing essentially as a squared minus 3a minus 4. And this guy here I know how to factor from algebra 1. So we're looking for 2 numbers that multiply to negative 4, subtract to negative 3. And that'd be negative 4, positive 1. Once I've got it factored out, then I go ahead and I substitute that x squared back in. Do you have to do that a step? Absolutely not. You don't have to. If it helps you, by all means, add it in there to see it. And then here is our new factored equation, but we're not completely factored because I see this guy here, and that's a difference of 2 squares. X squared is a perfect square, 4 is a perfect square. I'm subtracting them. So I can factor that further as x and x. Square root of x squared is x. Square root of 4 is 2. I make one positive, one negative. It doesn't matter which one's positive, which one's negative. For the second guy here, I do have a perfect square, x squared. I have a perfect square 1. 1 times 1 is 1. But it's not a difference of 2 squares. It's a sum of 2 squares. And sums of 2 squares are not factorable. They're what's called prime. So not factorable. And then to find out what these are the factors, so this is what g of x is when you factor it. But they don't want to know what are the factors, they want to know what are the real zeros. So we're going to set each of these guys equal to 0 and solve. So this would be x equals -2. That's a real number. Here's 1. This would be x is equal to +2. Again, another real number. This one I have to do a little work. I've got x squared is equal to -1 when I move the 1 over. When I take the square root of both sides, I've got x is equal to plus or minus the square root of -1. So my zeros are -2, 2, positive square root of -1, negative square root of -1. So those are all my possible zeros, but they're asking for real zeros. So the only two we're worried about are these two. Why not this one over here? Because it's got a negative inside that square root. This is not a real number. Remember, this is I. It's an imaginary number, and they didn't want the imaginary numbers. They just wanted the real zeros. So yes, it has 4 zeros. Only 2 of those zeros are real, and we have at most 2 turning points. We're going to talk about graphing tomorrow. All right, for A, again, I'm going to write this in this quartic function in quadratic form by making this x squared, and then minus 9 times x squared plus 18. So this is really like a squared minus 9a plus 18. And so we are looking for two numbers that multiply together to give you 18, add up to -9. And that would be -6, -3, and instead of putting a here and here, I go back to putting x squared. Now we're going to solve these guys. So x squared is equal to 6, or x squared is equal to 3. When you take the square root of both sides, I get x is equal to plus or minus the square root of 6. X is equal to plus or minus the square root of 3. So I've got 1, 2, 3, 4 different zeros here. Are these guys reals? You betcha. There's not a negative underneath the house, so it doesn't matter that it's square root. It matters if there's a negative under the square root. So these guys are, all 4 of these are real solutions. And then I forgot to do this at the very beginning. That 4 means the possible zeros we have is 4 possible turning points. It's always going to be 1 less than the zeros, so 3. All right, looking at B, let's start with that part. Possible zeros for B would be 5, and the turning points would be 5 minus 1, which is 4. All right, for h of x, I can factor out a common factor first. So they all have an x in common, so I pull out the x, and I get x to the 4th minus 6x squared minus 16. And then notice it's going 4, 2, 0, just like these other guys, right? And so now I know I can put it into quadratic form. So this is the same thing as x times x squared, minus 6 times x squared, minus 16. And so we've got x times, this is like a squared minus 6a minus 16. Two numbers that multiply to -16, subtract to -8. That would be 8 and 2. I need it to be -6, so it's going to be -8, positive 2. And then instead of putting the a in, I'm going to put the x squared back in. Can I factor this one any further? Nope, I don't have any difference of squares here, no common factors to pull out. So I've got x is equal to 0. That's real, so I'm going to go ahead and put a box around that one. This one would be x squared minus 8 is equal to 0, or x squared is equal to 8. When I take the square root of that, I get x is equal to plus or minus. 8 breaks down to 2 times 4. 4 is 2 times 2. So a group of 2's can come out with this lone 2 stuck in jail. It's not negative underneath the house there, so these 2 solutions are real, so they get inflated. And then this last guy here, that would be x squared plus 2 is equal to 0. If I move that 2 to the other side, it would be x squared is equal to -2. When I take the square root of this one, unfortunately, though, it's plus or minus the negative square root of 2. So these are 2 zeros, they're just not real zeros. So here's 1, 2, 3, 4, 5. Those are my possible zeros. Only 3 of those zeros are real zeros, though. All right, so that's it for video 1. When you come back, we're going to talk about multiplicity so that we can get ready to graph these guys tomorrow.